Choose all of the numbers that are factors of the given number. Remember, a factor is a number that divides the given exactly or evenly without any remainders. So 6 divided by 2 would come out perfectly with no remainders. 6 divided by 3 also would leave no remainders. 6 divided by 4 would not be a whole, or divided by 24 would not be a whole number. And 6 divided by 12 would also not be a whole number. So the factors of 6 in this problem are 2 and 3. Here, in 75, 1 times 75 is 75, so that works. 3 times 25 is 75. 25 times 3 is 75. But 750 is too big. If I were to divide 75 by 750, I would have remainders. So go through and circle or write down the list of factors for the provided numbers. The game you will be playing in this lesson is called Factor Find. So an example of a factor. 2 and 4 are factors of 8 because 2 times 4 is 8. The first player chooses a number from the board. The number this player chooses is the number of points he earns that round. The second player earns points for any other factors of the number that the first player chooses. So, for example, with 8, the first player would get 8 points. The second player could get points for 2 and 4, which would be 6, and any other factors of that number. So it says, now the chosen number and all of its factors are removed from play. Players take turns choosing the number. The game continues until there are no more numbers left to choose. The player with the greatest number of points wins. So it says display the factor find game, and you're going to choose a number. You're working with a partner. So let's start with 8. If the first player picks 8, the other player gets factors for 4 and 2, because that would make 6, and then 1 and 8, but the 8 was already taken. If the next player chooses 10, they would get 10 points, and the other player would get points for the 5, but the rest of them were already taken. The 1 and the 2 were used up for the 8. If this player chooses the number 37, the only factor of 37 on the board would be 1 and 37, but the 1 was already selected, so it is gone. Then maybe you're going to choose another number that is prime, like 17. So that way this player doesn't get any points. About 31. 29. Maybe 23. 13. We're looking for the prime numbers first because those are going to give us points, but not our opponent very many. 39 uses 3 and 13, but 13 is already taken, so our opponent would only get 3 points. 35 is 7 and 5, but the 5 has already been taken, so our opponent would get 7 points. 34 is a 17 and a 2, but those are already taken. 33 wouldn't be super fantastic because the 11 is still available. 36, that 12 is still available, and the 6. 21 is 7 and 3. Both of those are already taken. 27 is 9 and 3. The 9 is still available. 26 is 13 and 2. Both of those are taken. 25 is 5 and 5. The 5 is already claimed. 30 could be 15 and 2 or 10 and 3. That 15 is still available. About 11. 19 is a prime number. So you're going to go back and forth playing this game with a partner or maybe a parent at home. The strategies we used, we started with prime numbers so that our opponent wouldn't have factors to earn points. What mathematical questions might the person in this picture need to answer to tile this region? This person may need to know how large the area he is tiling will be. He'll probably also need to know the size of the tiles. What to do if it doesn't fill the whole space. Does he need to leave a gap? Does he need to use a piece of a tile? It says, find the length of a square tile other than 1 foot that tiles the 30-foot by 24-foot rectangle completely. So here, the square's tile side length is 1 foot. So you can see that it would take up 30 across and 24 tiles tall. But it asks us to use something other than a foot. So let's look at maybe 2 feet. We could fit perfectly across the width and perfectly for the height. So we could use 2 feet. Is this the only side length that works? No. We know 1 foot works. How about 3 feet? Three feet works. 4? Not perfectly. About 5. It fits that way. Oh, but not that way. 6. Yes. And yes, so 6 feet also works. Oh, we missed 3. 2 feet, 3 feet, 6 feet. So 1 foot would work, 2 feet works, 3 feet works, and 6 feet works. And why? 1 2, 3, and 6 are all factors of 30 and of 24. 1 times 24, 2 times 12, 3 times 8, 6 times 4. Maybe try 4. Oh no, 4 doesn't work for 30. 1 times 30, 2 times 15, 3 times 10, and 6 times 5 all make 30, so those are all factors of 30 and 24. 4 is also a factor of 24, but 4 would leave remainders for 30 feet. Number 5, what are the side lengths of square tiles in feet that can tile this rectangle completely? Well, 1 is a factor of every number, so we know 1's going to work. 2, both of those numbers, 48 and 36, are even. So 1, 2, I know 3 works for 36, and it works for 80. How about 4? 4 works for 48 and for 36. 5 isn't going to work. 5 times 7 is 35, but we won't be able to get 36 using 5s. 6 times 6 is 36. And 6 times 1, 2, 3, 4, 5, 6, 7, 8 makes 48. 7. I don't think 7 will work. 7 times 7 is 49, but we won't be able to get 48 using 7s. 8 works for 48, but it doesn't work for 36. I know 9 works for 36, but it will not work for 48. 10. In order to be a factor of, or a multiple of 10, you would end on a 0, so it would be 50 and 40, but not 38, or 36 and 48. 11 times 4 is 44. 12 times 4 is 48, and 12 times 3 is 36. 13, no. 14, no. 15, no. Maybe 16, does it go up that high? 16 works for 48, oh, but not 32. 17, no. 18 doesn't work for 48. 19, no. 20, no. 36. It would work in one direction, but not the other. What are the side lengths of square tiles and feet that can tile this 5 foot by 4 foot rectangle? 1 definitely works. 2, nope. 3, no. 4, no. And 5, no. So just 1 foot tiles will tile that section. How about 18 and 12? 1 works for all of them. 18 and 12 are both even, so 2 will work. 3 times 6 makes 18. And 3 times 4 makes 12. 4 does not work for 18. 5 does not work for either. Our multiples of 5 are 5, 10, and 15. 6 times 3 is 18, and 6 times 2 is 12. 7 won't work. 8 will not work. 9. The only other option would be 12, but that does not work for the 18. And it does say, how do you know? Well, I know 1 times 12 is 12. And 1 times 18 is 18. We know 2 times 6 is 12. And 2 times 9 is 18. We said 3 works. 3 times 4 is 12. And 3 times 6 is 18. We also said 6 works. And that is because 6 times 2 is 12. And 6 times 3 is 18. What do you notice about the side lengths of tiles and the length and width of the rectangle? I notice that the length of the rectangle and the width of the rectangle are multiples of the side lengths used for the square tiles. 30 is a multiple, or 30 is multiple 1s, multiple 2s, multiple 3s, and multiple 6s make 30. Now let's see if you can use rectangular tiles to create squares. Using 3-inch by 2-inch rectangle tiles, what is the side length of the square you created? So we're trying to create a square. As soon as you get a square, it's going to turn green. Let's try a 10 by 10. Oh, that looks like it's 9 because 3 times 3 is 9. How about a 12 by 12? Yeah. 3 times 4 is 12, and 2 times 6 is 12. So what is the side length of the square we created? It's 12 inches. Is that the only square you can make? Well, let's keep going and see. Oh, I can make an 18 by 18. Or maybe a 24 by 24. Why am I able to make these other squares? 18 is a multiple of both 3 and 2. 3 times 6 is 18, and 2 times 9 is 18. Same as goes for 24. 3 times 8 is 24, and 2 times 12 is 24. So they are multiples of both numbers. What are the side lengths of the squares in inches that you can create using a 7 by 10? I need to think about my multiples of 7 and my multiples of 10. If I create that list, I have 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, and that list for sevens goes on and on. 10, 20, 30, 40, 50, 60, 70, 80, 90. The only number that appears in both, meaning it's a multiple of both 7 and 10, is 70. So we're going to create a 70 by 70 square. And this is in inches. What are the side lengths of the squares in inches you can create with a 7 by 10? 70 inches. What is the side length of the smallest square in inches that you can create with the 6-inch by 4-inch rectangle tiles? Let's do the same thing. 6, 12, 18, 24, 30, 36, 42, and if we did 4, that'd be 4, 8, 12, 16, 20. The smallest number that appears in both lists is 12. And how do we know it's the smallest square? It is only 2 wide, or 2 tiles wide. If it were 1 tile wide, it would be 4 inches wide, but we can't get a 4 by 4 because it's 6 across. Or I have that backwards, but it's 6 wide and 4 tall. The next one would be 8, but we've surpassed the 6. So it is only 2 tiles wide. That is the lowest number that we can use. Number of tiles that we can use. We also created that list and you saw that it was the lowest one they had in common. What is the side length of the largest square in inches you can create? How do you know if it's the largest square? Okay, well, if we can create a 12 by 12, we could also create a 24 by 24 or a 36 by 36 because these are multiples of 12, and a 48 by 48. Are we ever going to get to the largest? Because we can just keep going. Larger and larger squares. We will never reach the largest square possible. For this picture, we could max out our picture, but if our axes continue on and on forever, then we can continue to create larger and larger squares. What do you notice and wonder about the side lengths of the rectangular tile and the side lengths of squares it creates? So I see that 3 and 2, they are both factors of 6, factors of 12, factors of 18. You could also say that these are all multiples of 3 and 2. And same goes for these. All of these square side lengths are multiples of the length and width of the tiles. Make sure that your warm-up is complete and any notes that you need to take in your workbook are filled in.